Okay, I think there is a question, when are we going live? Hey, hi Nishant. Hi everyone. Hope you're doing very well. I'm Mudat. I'm one of the founding members of DeFi. Super happy to have you with us today. For those who are new to this, so I think a lot of you might already be a part of the bootcamp that we're running in collaboration with Analytics Club at IIT Bombay, but a lot of them might be new to DeFi. So a very warm welcome to all of you. For those who are viewing it live and for those who will be viewing it later on as well. Praveen is with us, whom I'll be looping in very shortly. He's someone who will be leading to today's session, and you as an attendee can feel free to ask any question that you have related to cracking interviews, entering into data science as a fresher, or whatever you might have. To give you a brief intro about DeFi first, I'll quickly do that. Just a moment. So, by the way, if you can hear me loud and clear, please feel free to drop a hi or something on the comment section so that I can know that. I believe we're live though, but yeah, I think just to be on the same page. Yep, people are there, but yeah, okay. So to give you some context, I think you can see my screen, right? So this is DeFi.tech website. Anybody who's joining the website for the first time should go to this particular section at DeFi.tech/community. You'll see there are courses, challenges, boot camps, and live sessions here. Boot camps are where we run these particular cohort-based courses. These start on a fixed date, end on a fixed date, and the idea is that it will take you from point A to point Z, let's say, and you just have to be there. It's very intensive. It's highly project driven. Okay, and you get to learn with other folks as well. So you can network with other data scientists. These may be beginners, or somebody of them might be very senior as well. People who have joined in via the bootcamp, you might be from, the community members might be from these two boot camps. Apart from this, we have a data engineering bootcamp as well. One interesting thing that we do apart from this is, hey, hi. So yeah, by the way, thanks Benson for dropping in your introduction. Others may also feel free to do that. That they can engage with each others. So on DeFi.tech/live sessions is where you can go and see the live sessions that we conduct. Okay, we'll be listing a few more here. We have live sessions lined up till September as of now. But you can just log in and start exploring which ones of them are of interest to you. Right now we are in this one. Tonight we'll also have one more session. I mean, tonight or today evening, depending on where you're joining from. There is one more session with Adam, who is a very seasoned educator. He's someone who is a community leader at Plotly, which is a very popular open source Python project for data visualization. And he'll be properly taking you through the steps around building analytic web apps on Dash and Python. So anybody who wants to join that can register via here. Now, jumping right into this particular session, I think I wouldn't read it out, but for those who do not know Praveen, he's a very popular face in the competitive programming industry. But for those of you who do not know about him, he is somebody who is a staff machine learning engineer at ShareChat. ShareChat is a really massive product which was recently backed by Google and has over 180 million plus monthly active users. He's somebody who has been with ShareChat from the beginning, I mean, from the early days, and now he's leading teams there. Before that, he has worked with DirectEye, LinkedIn, and other organizations. So this way, he's somebody who comes with an experience of working with both startups and enterprises. So whether you have questions around, which kind of industry you should go for, and or how you can enter, or even the technical side of things, which is what Praveen will be sharing, you can feel free to ask questions around it. So without any further ado, I'll just stop sharing my screen and I'll loop Praveen in. So yeah, 1 second. Hi Praveen, how are you?
Hello, hi Madhit, I'm good. How are you doing?
I'm very well. Thank you so much. Super happy
Am
to
I
have you
live
here.
now?
Yeah, yeah, we're live. We're live. People can see you across DeFi and
Thank
YouTube.
you.
So
It's
yeah,
my pleasure.
sorry. Am I
Hello
audible?
everyone.
I'm sorry. I'm
Pleasure
not.
meeting you all guys online. Yeah, so
Yeah,
maybe we can sort of ask. So am I audible properly?
yeah, you're audible. I think there is some network issue at my
Yeah.
end, so I'll let you take the lead. I'll just go
Welcome
to the back.
everyone.
Yeah, yeah. I'll
Sure,
just go
sure.
to the backstage. You can take
Let
the
me
lead. Yeah.
share my screen in that case. Uh, is my screen visible by the way?
Yes, yes. People can see it. Yeah.
Uh, Modit, is my screen visible?
Yes, your screen is visible, Praveen.
Hello? Okay, let me start the slides. So, yeah, so hello everyone. So this interview is regarding basically how do you tackle ML system design interview. So this will be slightly specific to ML system design only. So I will go into details regarding what sort of things are expected from an interviewer perspective, and from an interviewee perspective, what sort of things that you should take care. So first, let's kind of discuss what's typical like ML roles in the industry. So one of the like most common, hard title is data scientist. Typically in Indian context, data scientist is basically person who knows good details about modeling. So in some sense, it's quite matches with applied researcher or applied ML scientist. But in outside India context, and even in some of the companies in India, data scientist is a role is basically data analyst role as well. So that's why this terminology nowadays, people, most of the big companies are not using data scientist title. They would either categorize it into data analyst, or also data analyst is also called as like decision scientist. And if one is very much into research side of things, the role will go into like applied researcher or applied scientist. One of the third role, which is very important, and we will be talking more about that in this call, is the ML engineer role. So basically, so ML engineer role is kind of a combination of ML side of things, engineering aspects as well, and also of product as well. So it's kind of a mix and match role, and that's why it's pretty much a lot of hiring of this role across the industry. The fourth and specific research specific roles are basically, you could say, some domain roles, NLP related, computer vision researcher related. So these are like some of the roles in industry. So typically, so we'll be talking here about MLE profile, which is ML engineer. So the purpose of basically an ML engineer round is to kind of assess the candidate's capability with respect to data. How good is the person with data? Also, like, does the person understands product? Does the person kind of understand how to basically analyze data, how to get training data? So lots of things with data cleaning, EDAs, and lots of those operations. Quite a bit of aspect of this role consists of engineering, because it's a pretty engineering heavy role as well. The other aspect it needs is ML modeling aspect, of course, and final in, is like the person should be good in analysis. Two kind of rounds in industry. One is ML depth round, and one is ML system design round. So ML depth round is typically for ML scientists or researchers. So the thought process behind that round is that it is used to basically assess deep understanding of data science concepts. So there the interviewer will go more in, take one of the common modeling techniques, and will go deep into that and ask questions related to that. ML system design interview, on the contrary, is more holistic interview. The aim of this interview is to kind of understand how well can a person solve a problem using data science. So in that way, this interview is cuts across multiple domains, and it's a more broad interview rather than deep. We'll go in detail regarding these components. So meanwhile, if you have any questions, feel free to type. I will try to answer them. So typical machine learning development cycle is, so first aspect is just problem formulation. What's the problem? Why are you even solving that problem? Why is this problem important? What's the business impact of this problem? And now, let's say if you try to solve the problem, what's the end outcome of the application? and outcome of whatever solution you're proposing. And other thing is, can ML even be used here? How can it be used? What are like objective metrics? So these are some of the most important steps in problem formulation. It's more about like just understanding problem better. So that's like first aspect. The other second aspect is about data. So I identify your data sources. It's so these sort of steps basically. This step involves you to kind of reflect into you need to check with your event team or your team that manages fact tables and so on and so forth. The third aspect is like what kind of data would you be generating, how do you generate that, and then the kind of sort out thing people do is this model architecture. So that's one thing. And finally, you should know how good is a particular model. So that analysis quite faster. So in offline manner only, you should be able to see how good your model is, and is your model learning. So those sort of aspect. Also, you should be able to compare your model with respect to other models. And similarly, you should be able to these all components will come in aspects. So after you train your model, you basically want to use your model, you basically want to use your model, you want to deploy it to production and use for inference. So that's one aspect. You can basically go over scaling and all those sort of scenarios in this part. And the final part is how do you do A/B testing, how do you do experimentation. So this is the kind of, so these 4 or 5 steps are typically part of ML development cycle. So in summary, basically the interview also looks very similar to this. So you just have to kind of emulate this pattern, which is you formulate your problem, ID data sources, and training data, and engineering would you be using offline, online, and model deployment, inference, and finally you'll be going over what's the typical flow. So one question is design video feed for a social media platform. So you are working in Moz, which is an Indian social media platform. So it has a video feed. So one question could be how do you design a video feed for that? Maybe video feed for TikTok, video feed for Instagram Reels. So that's one question. It's related to recommender systems. The other question somebody could ask, like design such system. It could be basically document search. It could be podcast search. It could be podcast search, video search, or all kinds of like such problems. You could even be seen given an example, or maybe design Facebook search. The third sort of question could get is design ETA prediction, design classroom recommender system, similarly acyclic prediction system, named entity recognition. So these are like some 5 or 6 most common examples that I found on internet. So you can prepare these 6 at least. You can go deep into these domains at least. Go over the very first aspect is like what's the problem formulation. So basically the first thing is what's the problem. Why do you even want to solve this? So for example, if your use case is, let's say, design a search system for, let's say, YouTube. So you want to design a search system for YouTube. How would you work? So user will type a query and you will be showing some videos for to the user. Also, like from business perspective, how is it useful? So essentially, it will lead more if user searches more. So it will increase basically the session spent, number of sessions, and average session duration, time spent on the platform. So these sort of metrics, also the retention. So all of these metrics will lead to more. We can show the users more advertisement, and we can nudge people towards like a premium. That way, more the user use due to this feature, it will essentially generate value for the business. So that's kind of like a business perspective for this problem. The other is like, what's the outcome of this search system? And let's say, so if you are kind of designing this, what's the end aim? So you could say essentially, I want some 100. So essentially, what would be your API basically? How? So that's one thing you could also, you can discuss. So, and other thing is essentially the effect we have already discussed. Essentially, what sort of relevant videos can you suggest? Business impacts we have already discussed. The third aspect is this requirements. So requirement is basically you can here ask for essentially what are your assumptions about the system, what's the scale of the system, uh, how you can ask like how past how past do I have to go in. uh, so basically like do I need to show 1 year old videos? So you can basically
Praveen,
make those sort of requirements more, you can clarify those sort of requirements. Can I be showing short videos, large videos? What's the aim? Can I also show YouTube shorts? So what sort of ideas that you can come up, you can ask those requirements basically. So
Praveen, hi.
that will come in
Sorry to
this
interrupt. Can you
requirement
hear me?
section. So other thing is you have to ask, can ML be used for this problem? So let's say you just, if you don't have, let's say, enough videos on your system, does it even make sense to use ML? Can you just, so these sort of aspects you have to clarify. So if the ML is not necessary, make sure you are basically, you check this requirement. And finally, like you just keep this trade-off between impact and cost. So essentially, whatever you're going to propose, it will have some cost and some impact. So this trade-off you have to keep throughout the interview in mind. So typically, this will be in. So this problem formulation is kind of similar to system design, except that here you have to discuss less about API, more about like business use cases and actual like what sort of metric you are supposed to improve. So when I mention this business perspective, you can basically talk about those metrics. So for example, I talked about some of the metrics here. So that's first aspect. So let me check if I have questions at this stage.
Yeah, hi, Praveen. Probably can you try turning off your video? People are facing some issue in regard to the audio.
Okay, let me.
Yeah.
Is it better now?
Yeah, yeah. It seems to be much better. Yeah, yeah.
Okay, sorry about that. I did not know that. Okay, so today, let me kind of then repeat a bit. So typical interview examples I mentioned. So let me go through that some of the persons again in case people did not get that. So I was mentioning the component of the interview is basically problem formulation is the first aspect. Second is uh, what are your data sources? How do you collect your data? Third is how do you basically build your training data? What sort of feature engineering you do? So what sort of features can you come up with? And the um, fourth aspect is modeling. Basically, what sort of model do you use? What are their benefits and what are their basically cost versus complexity sort of trade-offs? Then you have to basically do offline versus online evaluation. And final when you have like trained your model, you deploy it to production, so that part will come into model deployment. So in inference is basically making requests to the model in production. Final aspect would be A/B testing, which is experimentation. So typical interview examples I mentioned is video feed for a social media platform, and one could be design a search system for document search system, podcast search system, maybe like YouTube search system. You could be asked like ETA prediction, for example, ETA prediction for Swiggy, or some maybe ETA prediction for Uber. So these sort of questions could be asked. Or also like suggest top restaurants. This this question can be asked as well. Add click prediction system, named entity recognition, which is like given resume, can you kind of figure out the name of the applicant, or college, maybe work experience. So can you kind of extract this information? So this comes out in this domain of named entity recognition. So these are like typical examples. So if you kind of cover these six, uh, I think you will have good enough material to talk about. So the problem formulation is like the very first step, which is essentially you have to talk with the interviewer regarding what's the problem that you're solving, and why are you solving it, what's the use case. So the one example is, let's say we are talking about YouTube search. So let's design a YouTube search system. So the first thing is, what we are designing. We know it's a search system that we are designing, and essentially the system, user will come, it will write a query, the query will get auto completed, and then regarding that query we will be showing some top videos, and maybe they could be sorted by duration, or they could be filtered by some other metrics. The use case from business perspective is basically the user will be able to search more, and we would be able to watch more content. So that way the user would spend more time, number of sessions of the user will increase, number of session duration can increase, time spent on the platform will increase, and all of these things will increase user retention on the platform. So these are some three or four key metrics that will be impacted by our system. And if these metrics are impacted, the business impact would be that we can show user more advertisement, or we can nudge users towards getting going towards premium subscription. So these are advertisement, premium subscription, and mm, maybe YouTube can have some other business models. So it will impact all of those business models. So that's like the money part here. So then you have to ask for like requirements. So here you can ask basically. So one thing is that I mentioned filters basically. So do you need to take into account filter in this stage? So you might want to drop that requirement. So you might want to like question assumptions, which is like how how large is my user base? How many daily active users are there? How many like overall active users are there? Are there a lot of new users? So that you might have to like think about cold start problem. uh, Also like how many videos are there basically. Also you can talk about what sort of category of videos, so you can basically kind of get an idea of how large is the system. And based on that aspect, the very first question should be, can ML be used here? Is it even necessary? So if the ML is not necessary here, it's more like a system design interview than ML system design. So that aspect you can take care. And finally, essentially, this trade-off between impact, which is like the outcome or business value, and finally the cost. So this trade-off you should keep in mind, and you should be able to kind of explain. This aspect should kind of arbitrate all throughout your interview. So let me know if you have any questions till now. Okay, no questions till now, so I can go ahead. Okay, so problem formulation is clear. Let's go to overall basically system architecture components. So basically, whatever problem you are given, so first maybe think holistically on that problem. So let's say you are given this search system problem, which is uh, this YouTube search problem. So holistically, how will the flow look like essentially? So whenever user searches something, first part would be user will be writing a query, and that query will get auto completed. And after the auto completion of the query, this query will hit the backend for recommendation, and that backend system which is responsible for this recommendation, very first thing it should do is basically find out what are the candidate videos that it can potentially show to that user. And those candidate videos could be pretty large. So this is step is called candidate generation, or it is also called as retrieval phase. So in this phase, you would want to basically gather all basically relevant videos. So it's essentially like you would want to kind of get an overall good enough, large enough corpus that kind of covers users' interest. So it may not be very like fine tuned. You can basically get some 100K candidates, 100K candidate videos. So it's a very large set of candidates. And now from these candidates, I would finally want to basically send user only, let's say 10 videos or 20 videos. So that's kind of the process that will look like. So first step is candidate generation, get 100K videos. The second stage is now these 100K videos, I would want them to rank basically and kind of get, so kind of get a slightly lesser number of videos out of it. So this is kind of a ranking, some sort of, you can assume this is a funnel. And first part of the fun, so each of these steps will basically keep on reducing the number of videos to the funnel, and end of the funnel would be just like 10 videos or 20 videos. So in the light ranking stage, you will have some pretty light model because you will have to rank 100K candidates very quickly. So rank those 100K candidates and maybe find top 2000 relevant candidates or maybe 3000 relevant candidates. And then you do heavy ranking phase. It's also called like re-ranking phase. So in this re-ranking phase, you will want to basically get maybe only 100 candidates. So here you can use basically slightly heavier models. You can personalize more as well for user. So after this re-ranking phase, you can one phase would be like filtering phase, where you would want to basically filter users. If some videos has been already seen, you filter that video, or you can basically do some other checks as well. For example, you can check whether video is nsfw or the video some other like if the video is too short or these sort of criteria. Ideally, this filtering aspect should happen all across the layers. So it should happen in candidate generation, ranking, and all those layers as well. But it might happen that you miss these candidates in candidate generation, and so you would want to maybe make sure once more during this filtering phase. The last phase is basically make your candidates to be diverse so that you're not showing all the suggestions of very similar kind. All videos are like too similar. So you would want to basically inject some diversity before sending your final 10 candidates. Here you would also want to add maybe if you want to send some ad in between and those sort of things. So you can do that sort of blending here as well. So this is kind of typically how a search system looks like. And interview will only want to focus on one of these components because these components are like pretty huge in themselves. So you can basically ask from interviewer which part does he want to kind of focus more on, or the interviewer himself will basically guide you through the process. So let me know if you have any questions. Okay, cool. Yeah. So let's go to data sources. Let's talk about data essentially. So data is the pretty much system. So first is identify what are your data sources. How are you getting data? So the data is basically the user is taking actions on your system. So you might be having lots of events flowing in your system. If user is liking something, user is commenting, user is reporting some content. So all of these events flowing in your system is your data. Other is like fact tables, which is like factual information. In some sense, you could say about user, which is like what is users' gender, what is users basically, demographic information, what is IP, what is location, city, or you can also have information regarding user actions. So what sort of things has user done in the past? What sort of interest does the user have? So all of these are like are your potential data sources. The other data source could be third-party data, essentially. So this is typically true for web trackers or Google search sort of systems. And you can also make use of publicly available data sets. Like you can, there are lots of open source data sets. Maybe you may take like Wikipedia information. So lots of data sets for various problems are available. So these sort of data sets you can understand. And also make sure to kind of learn about the company that you're interviewing and what kind of data is does the does the company has about a user. So that will give you kind of information. So data sources could be basically this offline and offline online data sources that will go later. But yeah, so let's go to basically like feature selection, which is like what sort of what could be the potential features you may think about. So this is like pretty important, and here you have to think very creatively and figure out what sort of features could be there. So very first thing is like identify entities in your system. Which entities is basically what are the main actors in your system? What are the main actors in your system? For example, in video feed, user is one actor because user is taking actions. Also, post ID is one, post or video is one other entity. Creator is similarly other entity. So these sort of information could be entities. Similarly, you can define categories as well. For example, you could have document category as one entity. In YouTube, maybe some video category could be one entity, video genre could be one entity. So essentially, these are your entities of the system. And you can think of your features as basically entity specific features or uh, entity specific features. Let's go through the first part. So for example, user specific features, user is one entity, or post video specific features. So user specific features, typically you can have user demographic information, what's user's age, what's user's gender, what language user prefers, what location does the user has, all sort of this demographic information you can use. How long the user has been on your system. This is one part. The other thing is user events or user actions you might have had. So you can have those as well. So user interest you can capture, user historical engagements you can capture. So these things are like information regarding user that you can potentially use as features. Similarly, like entity action specific features, which is what sort of actions is entity taking on your system. So for example, for a YouTube video, I can like it. Earlier I could even dislike it. I can share a video, I can report it, I can comment on it, I can follow something, I can subscribe something. So think about all sort of actions that you can take a user can take, and essentially make sure that you can create some features around that. For example, for user like, you could create user like counters, depending upon like hourly counter, day wise, or 7 day, or maybe overall counters. So these sort of think about actions, and from that actions derive your basically features. The other aspect is basically cross entity features, which is in this case, let's say user comma genre or user comma document category features, or you could have user comma channel interactions, user comma maybe author interactions, and these sort of information you can capture. And last but not the least is context specific feature, which is the context in which the request for uh, recommendation is being made. So capture that information. It is like what's the current time, what's the hour of the week, what's the day of the week, because these two information could be important, because in morning you might want to show different content, evening you might want to show different, maybe on weekends you might want to show different uh, content as well. So similarly, IP location information, if you can use phone model is one information that you can use. It essentially uh, kind of tells about affluence of the user. Similarly, device manufacturer, network information you can also use in as a context feature. So network information could be, is the user on Wi-Fi network, which is faster. So that way you can use these sort of informations. So similarly, you can come up with like more features. My system is stuck a bit. Let me know if you have any questions till now. I would be happy to answer. Somehow my screen has stuck, so I'm not able to proceed to the next slide.
Hi, Praveen, do you want me to share my screen? I mean, do you want me to present it on my device?
Just a second. I think it got unstuck now. Let me
Okay.
see. Is there any questions? So one question is this a standard pattern for all companies? Not necessarily. It's not a standard pattern. Uh, but lots of companies follow this pattern, and more or less for ML engineers the pattern would be similar. It could differentiate a bit, and for all those difference the interviewer will typically guide you into the right direction. If you're spending too much time on data, they will guide you to proceed faster. So that part, but in summary, you will, lots of it is common across interviews, across companies basically. Sure. So let's go back. So that was about like kind of features that you can have. Let's go to feature engineering aspects basically. So how do you kind of represent your features for the model? So essentially, first thing is if your feature is a categorical feature, it's, for example, gender could be male or female. Similarly, there could be like multiple categories as well for various features. So you would want to make sure that one possible representation is like one hot encoding, essentially like for each of the category you have either 0 or 1 depending upon that category is present in the feature or not. So for these sort of features, make sure to like handle unseen categories, uh, because you can have, if this one not encoding will have a fixed encoding size, encoding length, and if your category does not lie into some of the categories, then make sure you have either other category or some way of handling that. So that's one feature. The other sort of features could be like numerical features, which are some examples could be like counter feature. Each numerical feature, hourly likes by on a particular video is in counter feature. So make sure like you can do uh, maybe normalization, you can do additive smoothing, these sort of operations you can perform over numerical features, or you can basically add more representation of nuclear. Basically, you can have maybe log of the counter, square root of counter. So these sort of like extra information you can try to add to your model as feature engineering. The other aspect is basically like feature hashing. So essentially, it's pretty similar to like encoding aspect, except that this time you hash the information, and so this can cover basically larger space. It will have problems related to collisions, so make sure you have your uh, modular size on the head has good enough. So these sort of things you can have. This is a really good reference for learning about feature hashing. The other type of feature engineering, which is nowadays being used quite frequently, is embeddings. So embeddings are could be of like any lots
Praveen, are
or
you
lot.
Praveen, I'm so sorry to
Yeah,
interrupt.
is it?
Your screen is not visible. Can you share that?
Yeah. Okay, let me share again.
Yeah,
Is it visible now?
yeah, yeah. It is visible now. Yes,
I'm sorry, you are not audible to me. Is it visible?
yes, yes. It is visible. Yes.
Okay,
Yeah,
so basically, let me talk about embeddings. So the very first thing could be it could be
yeah,
content embeddings basically. So let's say if your text content, which is like maybe description, video description sort of thing, so you can have their word-to-vec embeddings. You can basically make sure you know how to word-to-vec, at least some ideas about that, because if you mention this word, they may ask that question. Similarly, like word-based embeddings for text is like very popular. You can be asked like image-based embeddings and video embeddings are like some other examples of content embeddings. So these embeddings just take like the content representation and directly embed that. So this is very fast type of embeddings. The other embeddings you can generate based on like interactions or on the system. So basically, if based on user video interaction or user item interactions, basically. For example, in Twitter, they generate embedding based on users interaction on tweet. So that way they generate embedding for both user and tweet. Similarly, in Pinterest, they capture user interactions on pin. So these sort of interactions you can basically observe and train embeddings from that information. So similarly, like query to document and query to maybe store. So these sort of information you can have. So uh, this is like one sort of embeddings that you can train. The other potential ways of embeddings you can mention, which is like autoencoders you can mention, or embeddings for learning some specific tasks. So these sort of embeddings you can mention. One aspect you can mention is this transfer learning, which is basically like use the already trained model information and get an embedding out of it. So typically, like transfer learning is you take already trained model and you fix first few, like you remove last few layers and basically retrain your model. You could even basically just remove the last layer and could use the remaining few layers as an embedding itself. So this is one way of embedding generation. You can go through these resources. They kind of explain you in detail how do you train these embeddings, how do you get those embeddings. So you will be, these resources are really detailed and will be very helpful. So let's talk a bit about training data generation. So one way could be like human annotation. So this part is helpful when you are doing you don't have data from your side, or you want basically better quality data, you want data augmentation sort of thing. So human annotation is of course one area that you can look. Other is like you, if in from your system you will be having your data warehouse, so run offline queries from that, and you should so these, the last two aspect we will cover later. So now come to, let's come to model architecture and training aspect in general. So the very first thing is start with very simpler models and progressively move to higher order model. So the very first thing could be even rule-based systems. For example, if you are doing this, let's say resume, maybe name recognition or these sort of system, you might come up with some solution based on rule-based system that for a first solution that should be fine. The next stage could be train a logistic regression model. Similarly, then you can go over these more and more complex models, decision trees, neural nets, graph neural nets, reinforcement learning, or lots of such aspects you can go. So the thumb rule is typically cover, you might have to cover only two or three of these. So start with logistic regression and decision trees, because these two things people know very well. And so if you know these two very well and maybe bit about neural net, you can go over these three components first. Also mention, why do you need a complex model? What does it capture that smaller model was not capturing, and how much, also like how much data typically does your model require to train. So keep the cost of like training larger and larger model in mind. So sometimes you can be asked a question like, why are you training such a large model? What are the added benefit of it? So it should be, let's say you want to evaluate two particular models. One takes, let's say, twice the cost of the other, and does, what sort of AUC gap would be good enough for you to justify that cost? Can you make like such comments in offline manner, or would you, so how do you think about these approaches? So think about complexity aspect as well. So some of the questions, if you go through these model architecture, that person can ask is regularization aspects, basically, all across these models. Essentially, relate that to basically bias variance trade-off also. Uh, you can be asked about details about your loss function, essentially. So make sure you get that right. Also, like training process, how do you train it? How do you split your data, and these sort of things. So these are like typical things that can be asked in model architecture and training component. Any questions till now? Okay, no more questions. So let's go to next section, which is offline versus online evaluation. So basically, the offline metrics for a particular model could be what's the accuracy of the model, what's precision, call, FN score, etc. So these metrics are basically offline metrics. You can compare maybe two models by their AUCs. So you might, most of the times in interviews, people ask questions regarding uh, why don't we use this metric versus that metric, which metric make more sense. So these sort of questions can be expected, and so have a like slightly better understanding of these things. Also, like F1 score at K, AUC at K, some particular number. So these sort of things can be asked as well. For ranking, typically NDCC and MAP are two common metrics that people use. metrics that you may be asked about them if you're talking about a ranking problem. So I have linked two resources. You can go through them and they explain these metrics along with examples. So you should be able to get that part right. The next part comes like online evaluation, which is you deploy your model in production and it is running online. How do you evaluate your model? What will be the important aspects of your model? So essentially it could be what sort of metrics this model is improving. So you could have maybe this model may be improving time spent, number of sessions, session duration, maybe retention rates of this model. Also, like if you are developing a model for searching, so how many searches are users performing? Are users performing more search, or how much time is user taking for a search to find the relevant results for it? So if a user is searching for very similar thing, it could be the case that your model is not performing that well. User has to use more searches, so it may not be that good as well. Similarly, for advertisement system, what's the click-through rate? What's the revenue? These sort of things you can capture in online evaluation to measure your particular model. So let's go through some of the important topics that you must know about. And so these are basically some of the common modeling aspects that you can be asked. So collaborative filtering is one very common uh, in recommendation system. So essentially, it kind of makes use of similarity based information. So let's say two users are similar, then maybe these two users' interests are similar as well. So, similarly, item based similarity. Let's say two posts are similar, and if you have liked one post, you may like the other post. So these are like thought process filtering. So you can be asked, you can mention maybe this. Similarly, wide and deep models is one of other techniques. Factorization machines, defactorization machines. So these things you can maybe learn about at least a bit, like what's the model architecture and how does it how each of these, what extra things do they capture, how are they different from each other. So this sort of information you can get. Other is neural collaborative filtering, graph neural nets. uh, so these things you can read about. Learning to rank, you should uh, read about. This is very important for like ranking aspects in recommender system. And finally, like how do you solve called start problem? So maybe you can mention some aspect about that as well. For NLP information retrieval, some of the common areas that you may want to look through is query understanding, completion, page rank, pre-processing aspect of your query could be one thing. TF, IDF vectors, similarly what embeddings could, and language models and machine translation are typically advanced sections. These are notes that I have thrown so that if you are preparing for one aspect, you can maybe look at these aspects and prepare about those. So in general, your ML understanding can be checked, like what's the difference between gradient descent and stochastic gradient descent. What is your loss function? What kind of loss functions do you know? Some questions could be asked regarding your training aspects as well. Sometimes maybe in theoretical interviews, you could be asked to basically show how back propagation works for neural nets. Some details about optimizers could be asked, how it works. So these sort of things are asked more into basically ML depth interviews. So for ML engineers, they will won't go into too much depth, but you could be asked about at least some information regarding optimizers. Similarly, activation functions. some basic aspect could be asked about these as well. Regularization is one commonly asked area, so make sure you understand that pretty well. L1, L2, deep learning based regularization, dropout. So these sort of things, make sure you understand them well. Variance bias trade-off is like pretty common thing. And model specific knowledge is like boosting, bagging, decision trees, random forest, XGBoost, what is attention mechanism. If you are preparing for like computer vision, you may be asked questions about CNN. Uh, so typically, these aspects are theoretical aspects, and these are asked more into ML depth round. But in the ML engineering round, you can expect to have question at slightly higher level. They won't ask you to go into maths or much deeper details, but you can at least expect to have some understanding of these concepts. That would be helpful. Let me check for questions now. Okay.
Yeah,
This
hi Praveen. So
question
there are
differ
two
on
questions. I'll probably pick
experience
them one by
level.
one.
Okay, so Bell asks, how does these questions differ based on experience level, and what do companies like LinkedIn, ShareChat look while hiring university grads? So typically for university grads, uh, people right after the university, we are not expecting kind of any ML role for ML engineer. So even if you are very new to ML, we can take you for ML engineering role. So it's and then basically for where freshers we expect their like logical abilities more, and slowly they can basically like transition towards ML roles. If you have ML background at that stage, that helps a lot. This is the way we do in ShareChat. I think for LinkedIn and other companies in industry, even for freshers, they expect at least to have some understanding of ML, but they may not want like ML system design round for you. I'm not sure. Maybe for Facebook, I think uh, they may not have ML system design for an L3 role. They could just give you uh, maybe coding questions sort of thing. I'm not sure about this, so maybe please check about that. But in general, the kind of structure that I'm explaining, this is more relevant on like ML engineering. But even for like newer folks, uh, they may want to, they may not go deep into a lot of aspect of feature engineering, but at least some aspect of modeling, basically model architecture, at least do you understand logistic regression, do you understand decision trees? So they, it depends on like company to company. Logical abilities as in DS and algo, yes. So the coding round basically. For data scientist role, for ML engineer role, we expect coding abilities, and for data scientist role, we expect at least some part of ML depth, because data scientist role is more uh, into ML research sort of research side of roles.
Praveen, there is one more question that I'm probably this one around
Yeah, yeah. So Sharon is asking, if I'm transitioning from business analysis to data science, does my experience as a business analyst count when it comes to applying for job as a data scientist? From my personal experience, I have seen that business and analysts are typically really good with data, and that comes out really handy. So that experience should definitely count, because this is one of most crucial areas, and this is often like kind of in some sense neglected area. Uh, I would assume that this will come out really handy in terms of transitioning to data science. In ShareChat, I have not seen multiple examples of this. So I think this transition could be possible. It may require a lot of efforts from your side to maybe kind of do online courses and these sort of things. One aspect that can help, if you are already working with the data science team, if you can get into some project that they are working on, that can help you transition much faster. The Benson asks question in ML questions mostly tailored to NLP, or does it also apply to other domains? For MLE, I have seen people asking more about recommendation systems than NLP. For example, you most of the like big companies I have seen, they focus more on recommendation side of things than NLP. If you are like if you are specifically looking for basically NLP research role, then only you will probably ask details about NLP. Otherwise, I think you can even skip that component for ML in engineering rounds. Okay, let's go to the since there are no more questions.
Yeah, Praveen, hi. There is one question that probably we missed. It's by it's around, I'm not sure if this was answered. Yeah, will a forensic data analyst role require this much in the interview process?
Uh, Forensic data. So this is the so
The one above. Sorry, you might have to scroll a bit more.
okay.
Yes, I've put
Will
it
a
on screen
forensic
as
data
well.
analyst role require this much? So data analyst role does not require any of these components actually. Data analyst roles typically are centered more about can you analyze data essentially. So identifying data sources, can you write SQL properly? Can you do like complex SQL queries? So these sort of aspects are more important in data analysis. Essentially, can you figure out basically retention? Can you write query for maybe some complex queries? So these are like typical aspects that we check in data analyst role. Yeah, let me proceed then. So let's go towards like components of recommender systems. So as I mentioned, the very first step was candidate generation, which so you can have like maybe these sort of ideas. So for example, if you want to design candidate generation for video feed, so some of the like ideas that you can use is you can have basically popular videos as one candidate. So depending upon various signals, so let's say the most liked in one day, that could be uh, one of your candidates. The most shared content, most commented on content. Uh, so you can have one of those candidates based on this. So typically, like whenever this is like very fast idea, so you kind of saw your popular content. The other is like user base interest basis content. uh, so what sort of content has user interacted in the past? So if I'm interacting with one category of videos, let's say cricket videos, so I can be shown top cricket videos. Similarly, like user demographic information, so if I am from, let's say, Rajasthan, I could be shown Rajasthani songs. So these sort of information can be used. uh, One candidate could be based on following. So if I'm following some person, or if I'm subscribing some channel, I can be shown content of that channel. Similarly, category based could be one of the candidate as for example, I mentioned like cricket, I mentioned, so this sort of like in category based top content could be shown. This one is ANN is approximate neural uh, approximate nearest neighbor. So essentially, these sort of candidates are based on your embeddings. So let's say you have your videos in embedding space, and your user also has embedding. So for your given user embedding, you can find nearest uh, some vectors, and those vectors will represent basically videos. So you can recommend candidates based on that. So these ANN based candidates nowadays is like very popular in recommender systems. So you may want to, because embeddings are getting popular. So this part is very important. You can tell about that. Other thing could be like recent videos, which is like some of the videos are really fresh on your platform, and if you don't show them, they won't get any views. So just to kind of solve those video cold start problem, you would want your videos to get at least some views. So you could be shown those candidates. Similarly, there could be some promoted videos, there could be some advertisement related content, and many others. So here you can show your creativity and essentially think of even more ideas. How could you generate candidates? So this is typically the first flow, and the second and the third flow are basically like the ranking and re-ranking phase. So the only difference between ranking and re-ranking is the first ranking is typically light ranking and re-ranking is heavy ranking. Sometimes you can even skip both of these steps and merge them into a single ranking step. So that depends on problem to problem. So the ranking, first thing you should, when you're solving ranking, first thing is what's your objective. So it could be maybe maximize likes, maximize shares, maximize comment, maximize maybe watch duration, or maximize maybe session time. So for each of the objective you can train basically, for each objective you can train your model, which will basically predict what's the probability of a user doing that action. So essentially that is called point wise ranking. So now you have that information that these are the 1,000 posts, and for this user the probability of likes is the following. So you can, so what would be the so you can have, since you have, let's say in this example, two objective, maximize like and maximize share. And for maximize like, you will get one ranking based on the probabilities that your model output. Similarly, your model will output one more ranking for probability of sharing. So essentially you would want these two ranking or these two basically probabilities to merge. So that is basically how much weight do you give to first likes, how much weight do you give to shares. So these sort of things are called weight tuning. So these aspects also need to be taken care. There are advanced techniques in this which can learn all of these objectives simultaneously. So you can basically multitask learning. You can think about, you can at least mention about that in your interview. So these are like typical mechanism for ranking. The final aspect is diversity, because after ranking you would want to make sure your content is pretty diverse, it's not similar. So the very first thing is think about what sort of repetitions or what sort of similarities are harmful. So essentially, if there's too much content by same author or too much content by a single channel, that would be bad. If too much content on same topic, same genre, that's bad. Also, like too much all the videos are, let's say, recent videos, that would be bad as well. And if you are just on very old videos, that's bad as well. So you would want to make sure a decent mix of that. Also the video duration also, you would you would not want all the videos to be like 2 hours long, and not, you would also not want your videos to be maybe like 10 seconds long. So you want maybe a decent mix there. Similarly, similar audio, or you would not want basically a duplicate post, you want too many ads. So the diversity is all about thinking what makes your feed more diverse, what makes your system more cater to broader interest. So think about that. And typical methods are like, you introduce basically penalties related to your similarities. So if there's more similarity, you penalize more essentially. So that's sort of uh, techniques you can use to make your recommendations more diverse. You can use like advanced techniques like DPP, which is determinantal point process. This is like pretty advanced techniques. If you know about that, you can mention that. uh, I'll take some questions at this time. Let me check. So Sanjana asks, how much important are challenges on Kaggle from a hiring standpoint? Sanjana, from hiring standpoint, Kaggle challenges could be helpful if you are pretty new, because they will give you some idea about modeling aspects and also like data cleaning and lot of aspects. So if you want to do Kaggle challenges, those are really helpful for hiring. But I would not just be doing Kaggle. We should also like prepare specifically for interviews, because interviews are slightly different than practice. So we would want to make sure that we cover that breadth aspect as well. So other question is it just from project and problem solving standpoint, or do companies use them to shortlist candidates? I'm not sure whether people use Kaggle to shortlist candidates. Uh, Okay, I think that was all the questions. So now let's go to the most another important phase, which is now you have trained your model, you have done offline analysis on your model, and you are sure that your model is performing offline really good. Now you would want your model to go into production. So now comes the model deployment, model inference stage basically. So here you should understand about model runtime frameworks, which are like TensorFlow or PyTorch. So typically these are like two very common. Also like the serving platforms. So TensorFlow, there's like TensorFlow serving model framework. So you can use that. Triton is one by NVIDIA. You can use that serving platform as well. So these serving platforms basically provide additional capabilities over these model runtimes. So they provide basically monitoring related capabilities, micro batching capabilities, and also like simplify serving for you as well. Also, they have the common inference API, so that makes it easy for you to basically make prediction request for different kind of models. Also, if you know about ONNX, which is like model interpretability, so you can basically mention about that. Model versioning is one aspect that you should take care. If you are publishing a newer version, don't just overwrite it. Publish newer versions. Make sure you can revert your model. So those sort of things, basically, CI/CD pipelines would be similar for model versioning. Also, some mention here regarding hardware accelerators, GPUs, TPUs. Uh, how if you have deployed models on GPUs, you can mention some aspect about that. Similarly, you could mention at this point of time feature drift, basically. So the offline features and online features need not to be same. There may be mistake in online features, or there may be mistake in offline features. There could be logical errors. There could be data distribution errors as well. So these sort of things can be mentioned at this stage. Final part comes now you have deployed your model. How do you monitor your model in production? So model monitoring, very first thing is like you make sure your model inference request have decent latency. Whatever was their SLA, they are respecting that SLA, which could be like what is their P99 latency, average latency, is the throughput fine, or the number of errors within the threshold. So these things should be monitored. The other aspect is your basically model performance, which could be essentially AUC, these sort of metrics. All other online metrics you can track as well. And so So once you have like trained your model and deployed it, you might need to retrain your model depending upon use case to use case. So make sure if your use case requires retraining, you mention about that retraining aspect, some aspect about at what frequency would be retraining, or would here you can use maybe like transfer learning sort of aspect. Would you be doing like full retraining from scratch, or would you be doing retraining on the newer data? So those sort of aspect can come here. You can mention about like online training as well, real-time streaming fashion training. So these are some aspects that you can mention. One crucial aspect is feature monitoring, and this is very important because in real life the features between offline and online may not be same. So make sure you have tools for feature drift detection. Similarly, distribution shift basically. So you can log your prediction request and check whether their predictions are changing a bit, changing their distribution with time or not. Also log number of null features, number of empty features, or you can maybe specify thresholds for features, and you can count, you can keep track of the number of features which are within the desired threshold. So you make sure you monitor all of these things in production regarding features so that your model behaves properly. The final aspect is A/B testing. So A/B testing is about user segmentation. How do you divide users? What is control variant? What is test variant? Uh, the number of users that you're running your experiment on, are they statistically significant? You can expect something about that. Also, be careful regarding external factors that could be impacting your experiment. For example, if it is in holidays, or the user behavior could be slightly different, so you have to keep that in mind. Similarly, if there's some external event, those sort of events you should take care. Also, let's say if there was some bug on the system, the app was down or something, so that will impact your experiment. And the final thing is, you basically, a experiment is about a hypothesis. So you make that hypothesis, you test that hypothesis in online A/B testing, and you basically iterate over that hypothesis, which is either you discard that or you iterate over on top of that. So that's it from my side. In terms of slides, I have listed a lot of resources here. You can go through these resources. Grokking the ML interview, this one course you can do. It's really nice course. And Chip Huen's ML design is also good. You can, if you want to see mock interviews, so these are 4 and 5 mock interviews. You can go through them. It will give you a good, really nice overview. These 2 3 links are very detailed. You can kind of whatever I have told, these links cover that, plus they cover much more. So you should go through these links. And finally, if you have done all of this and want to read more about ML aspects in industry, you can go through these links. So this applied ML GitHub repository, this one is a very thorough repository of industry use cases. You can refer it even for your work, or for interviewing also it will help. This ML design patterns, this is book by, I think, Google engineers, and this one is a really nice book. uh, it mentions, it basically takes one design pattern at a time and basically explains that. So it's a very thorough book, a really handy book. If you want to know slightly in detail about recommended system, go to this link, and these are few another links that could be helpful. Let me know if you have any questions, you want me to go on any slide or anything. So
Yeah, hi
Benson,
Praveen. There are a few questions here. Yeah.
So let me. Okay, so Bela asks, are Kubernetes slash Dockers also important from model deployment interview question standpoint? Bela, no. Typically, like ML engineering down, they don't expect this part to know. But if you are really good in Kubernetes and if you understand about that, maybe you can mention a few lines that would be a stronger point about you. But it's not necessary for you to know that. But if you know, do make sure you cover this model deployment aspect, and you can show your skills there. And Benson asked, should one be concerned also with the data engineering part while working as MLE? Uh, yes, in your work, you will definitely need to understand data and also write your training queries and those sort of things. So you need to understand about data engineering, but you might not need to write ETL jobs in your work. It depends completely on the company to company. So for ShareChat, we expect like ML engineer to be a good software engineer as well. So that way, this data engineering part is covered there. But please check it according to company by company. It, it would be slightly laser focused than typical data engineers for sure, but you are expected to know a bit about it for sure. I will share presentation links for sure. If there's any other questions, do let me know. Maybe I'll go through all the slides in case like somebody wants to ask question from a slide. First one was just ML engineering roles in the industry. The second one was like system design. So here, as I mentioned, that the person should be good in data analysis. So this part is important. If you are a really good data analyst, it will help you a lot in your ML engineering career. ML development cycle, if you have any questions from this. The next one was components of the interview. These are like some typical interview examples. Make sure you do at least these, and if you find more on internet, do those. But at least cover these. Problem formulation is really critical. This kind of sets tone for your interview. So make sure you spend maybe 4 or 5 minutes on this. And here you have an opportunity to show your business understanding as well. So you can, if you can somehow show that here, that would be good. So basically, this one is overall component. This one will, this is problem specific. So whenever you mention your system architecture components, you will, most of the time interviewer will basically want you to focus on one of these areas. Data sources could is like one area that you need to cover for data. Feature selection, feature engineering, embeddings nowadays commonly used, so make sure you can cover all of these. Training data generation, model architecture is the one that people focus too much on, so don't focus too much on this, but it is like important for sure. It's kind of very important section, but don't focus like don't spend all your time on this model architecture. Even interviewer will kind of ask you to skip. uh, Make sure you understand these accuracy, precision, recall, F1. So these two resources are really good, and make sure you understand their definitions, and that will help you because typically interviewers ask these questions. If you are using recommender system, if you know about some of these techniques, that's a very strong bonus point for you. Similarly, in NLP, these are some keywords that if you know is really good. Make sure you cover these aspects: regularization, activation functions, back propagations. There may be some discussions regarding that. Decision trees, XGBoost, bagging, boosting. These are one. logistic regression. Make sure you understand these simpler models deeply before going into deep learning. Uh, in fact, like it may happen that in your interview, even if you don't tell more about deep learning just by basic ML, that part will, if that part is very strong, that will come out nicely. Then this was like candidate generation steps, ranking steps, diversity, model deployment and inference. This part, sometimes interviewer would want you to maybe skip that part, but if you are like really good in that part and you have worked quite a bit, this is the place to kind of show your skills. So you can mention some of, maybe briefly for 2 minutes or so, you can mention if you have, let's say, Kubernetes, if you use, let's say, Sheldon Core or KF server, some sort of tooling around that, you can mention that. If you have done model deployment on GPUs, you can mention that gRPC, this TensorFlow, basically this inference API. So these sort of things, if you want to mention, that would be a plus point, but not necessarily. Model monitoring is one aspect that kind of shows your experience regarding model deployment in production. So make sure you cover this section. This is pretty important section. Spend few minutes over that. Feature monitoring, feature observability, feature drifts, and these sort of things. These are also very crucial. So there are lesser questions on these, but if you mention these aspects, this shows your like deeper understanding about modeling aspect. Retraining is one aspect that you should always mention, because if you just train model once and then you are not thinking about it, it kind of shows that you have not worked too much on production. So make sure you cover those aspects. A/B testing is one final aspect that you can cover. Let me know if you have like any question related to any of these sections. Yeah, I would be sharing presentation link.
Yeah, probably what I'll do is I'll just post the link for the session on DeFi's website. We'll drop an email to everyone who has registered there. So that's an easy way to go about it. Yeah.
Sure, yeah, that works for me.
Yep.
So Dasan asked, what do you think about working big for as data scientist, data engineer? Uh, I'm not sure what you mean big for. Uh, in general, I
I
can
think
mention in ShareChat, my experience as basically ML engineer. So it's been like pretty nice. I have, since we are building video feeds, so whatever kind of systems that you mentioned, we have developed these systems in production. So I have deep expertise around that. So like essentially you have an hypothesis and you test that hypothesis over users. Sometimes your hypotheses won't work, and when they do, you feel really good about it. So in general, in terms of learning, it's been a really good experience that way. So I think it would be an enjoyable experience.
Praveen, just to add to it, I think by Big Four, probably Darshan is implying to those Big Four consulting firms, maybe the likes of KPMG, EY, Deloitte, and PwC,
I'm not sure about that.
or maybe okay.
I'm not sure about that. Sorry, I can't answer that.
Okay, great. Then so I think yeah, I think we are almost done with the questions. I've also added the link for for people to go and register. So we'll drop an email by the EOD for others also to so that everybody who's seeing this can actually receive this. So yeah, I think we are done with the yeah. Darshan says okay, thank you. So probably we answered his question.
So
And just to
from
share,
my takeaway, like just final few words. Even if you have, even if you did not get anything from this whole 1 hour, go through these resources. These are really good resources, and if you just do these two resources, your preparation would be really good. Make sure to go through the resources section. and I hope you find it useful.
Yeah, sure. It's very modest of you to say this, but thank you so much. And yeah, I think it has been a pleasure hosting you today. And we planned for 1 hour, but it's been around 1.5 hours. Thank you so much for sticking around and answering all the questions that people had. I'm super grateful on the behalf of the community, and we'd love to see you more and more if you have time for sure. But yeah, thank you so much, Praveen.
Sure, Mudit, it was pleasure talking to all. Thank you, everyone. It it was my it was my pleasure to talk to you guys. Thank you.
Thank you. Bye.